Today we'll be looking at a continuation of solving quadratic equations. First we're going to look at what we did. We'll review real quick. Previously, if we had a problem like x squared equals 9, we got it equal to 0, and then we factored. Noticing that this is a difference of square, we have x plus 3 and x minus 3 equals 0. And then because we turned it into multiplication, that means that either this was 0 or this was 0 to get 0 when we multiplied. So we set each factor equal to 0 and we solved. So we got our minus 3 and our plus 3. That's good, but was there another way we could have done this? What if we started right back at x squared equals 9? Isn't it true that we can use the opposite math operation to solve? The opposite of squaring is the square root. So if I take x squared equals 9 and I take the square root of both sides, wouldn't that also work? That would get us x. Remember though, either a positive 3 or a negative 3 would have worked to get 9. This method is another method we can use if we have something squared equal to a number. It's called the square root property. We're going to use that a couple times for practice. Okay. If we have 2x squared minus 16 equals 0, it's not quite set up yet for the square root property. So I'm going to move the 16 over, and we'll get 2x squared equals 16. And then it's still not quite set up because we can't take the square root of 2. So I'm going to divide both sides by 2. Now it's set up for the square root property. 16 divided by 2 is 8. I can take the square root of the left-hand side, so I'm going to. And then I will have to take the square root of the right-hand side. Remember, though, again, we still have the positive or the negative square root of 8. Here we're not done. We have to recall our properties of square roots. If we can simplify, we have to. And since 8 is 2 times 2 times 2, I can take out a perfect square from that. And so x is the positive and the negative of 2 root 2. You might also see this as x. Let me come over. You might also see that as x equals negative 2 root 2, comma positive 2 root 2. We can split them up or write them with the positive and the negative symbol. Let's look at another example that could come up where we can use this property. It doesn't have to be a single term. It can be a polynomial. So here on the left-hand side, we do have something squared. On the right-hand side, we have a number. So it is already set up for the square root property. When we square root a square, we get the base. This time the base was a whole 2 terms. And on this side again, we have the positive and the negative. Square root of 4 is 2. We're not done though. Our variable's not by itself. So we're going to have to keep simplifying. We're going to add 3 to both sides. So y equals positive 2 plus 3, which is 5, but it also equaled this negative 2 plus 3, which is 1. So we have 2 answers. And we're usually going to get the same amount of answers as we have as the power. So we're going to get 2. We have another situation. X squared plus 2x equals 4. What about this situation? If we get it equal to 0, will it fit the square root property? Well, I certainly don't have something squared all by itself on the left. Is this factorable? Well, let's check it out. Is there anything that multiplies to a negative 4 and adds to a positive 2? Well, 4, we have 4 times 1. and 2 times 2. With the negative, we could have opposite signs. 4 minus 1 is 3. A negative 4 plus 1 is negative 3. That won't work. And 2 plus 2 is 4, and 2 minus 2 is 0. So there's nothing that will work factoring. But remembering that for completing the square, we have a goal. Our goal is to have something squared equaling a number. Well, if we've seen something squared before when we were multiplying out. If we remember, if I had something like x plus 3 quantity squared, that led me to multiply it out times itself. That times that is x squared. X times 3 was 3x. 3 times x is 3x. And 3 times 3 is 9. That's good. Notice what happens here though. I have 2 of the 3x's. That's going to help us look for a pattern that we can use to solve this problem back here. There's 2, and if you notice, no matter what I put here, when I square it, I will always get that times that to match that times that. That's a pattern we can use. We're going to use it in something called completing the square. So we have our goal. What we're going to do is we're going to leave this the way it was originally. And we're going to figure out what we can add here so that we can get our perfect square trinomial. But remember, whatever we add on one side of the equal sign, we have to add on the other to keep it the same value. If you recall a few seconds ago what I had on the board, that middle term was always doubled. Well, if I can see what this was as doubled, I'm going to take the middle, divide by 2, and square the answer. 2 divided by 2 is 1, 1 squared is 1. But I'm going to write it that way on this side. And I'm going to go ahead and square it on the right. We have now put this into a perfect square trinomial pattern. I could factor it the long way. What multiplies to 1 and adds to 2 would be 1 times 1. But because I forced it into that pattern, I know that I can take the square root of this, I can keep that sign and take the square root of that and put the squared outside here. And then go ahead and do the addition. 4 plus 1 is 5. Now it fits the square root property. I can take the square root of both sides of the equation and get a positive and negative root 5. Again, we're not done solving. I'm going to have to subtract 1. But I'm going to put it in front of the radical. This really is 2 answers. I have negative 1 minus root 5 and negative 1 plus root 5. That is how we complete the square. We take the middle term, divide it by 2. Recall, sometimes we'll have fractions here, so dividing by 2 is the same as multiplying by half. Square the answer, and that's what we're going to add to both sides of the equation. Let's look at another example. Y squared plus 10y minus 26 equals 0. Again, it's not factorable, and it doesn't fit the square root property, so we're going to use completing the square. I know I'm going to have to add something here, so I'm going to go ahead and move the 26 to the other side of the equation, and then whatever I added on the left of the equal sign, I will add to the right. To get that number, I'm going to take the middle term, divide it by 2, and square it. 10 divided by 2 is 5. 5 squared is 25. We added 25 to both sides. This side, we know how it factors because we forced it into the perfect square trinomial. So I can square root this, keep this sign, and square root that, put it here, square the whole answer. And 26 plus 25 is 51. And now, square root both sides by the square root property. Y plus 5 is equal to a positive and a negative square root of 51. Subtracting 5 from both sides, we've got both of our answers. Negative 5 minus root 51 and negative 5 plus the square root of 51. That is the first case. There's one more case that makes this a little bit harder. And that is what happens when we have a coefficient other than 1 in front of our x squared term. Completing the square only works when our coefficient is 1. So what can we do if we have something like this, where our leading coefficient is not a 1? Well, we can use algebra. We're going to divide it out. So I'm going to divide every term by 3. So that'll give me x squared minus 4p plus 2/3 equals 0. And now I can move the 2/3 over. We're still going to have to add something here and here. And again, we find that by taking the middle term, dividing it by 2, and squaring the answer. This side will factor into the square root, this sign, the square root, and then remembering that we need a common denominator to add, I need to multiply this 1 by 3 to get that denominator, so I'll have to multiply that. That gives us 12 plus a negative 2, which is 10, over 3. Now I can go ahead and take the square root of both sides, which will leave me with my x minus 2 equals positive and negative square root of 10/3. We're not allowed to leave a radical under a denominator, so I'm going to multiply top and bottom by the square root of 3. And x minus 2 equals the positive and the negative square root of 30 over 3. And now I'm going to complete this process by adding 2 to both sides of the equal sign. Some people are more comfortable with this as separate. Some people are more comfortable with it as one fraction. I could, if I wanted to, make that 6 plus and minus square root of 30 over 3, but it is not necessary. So today we solved quadratics in the previous section by getting it equal to 0 and factoring. Today we've added 2 more techniques. We can, if we have something completely squared on the left of the equal sign and a number on the right, take the square root of both sides. That's the square root property. We also learned how to turn a trinomial equation into the form that we can complete the square and then from there use the square root property.